All right, so for the past couple weeks, we've been solving systems of equations. What was our very first method we learned?
Should be
Very first method we learned for solving a system. It was more visual.
Like there was a couple of questions on the test.
Think about it. Graphing. Yeah. And right, what did it look like when you graphed them? We were looking for where they what? Yeah. In general, if we were solving a system that had one answer for x, one answer for y, just one solution, we were looking for where the lines crossed. Now we saw they also could be parallel, so there was no solution. And then we saw they could have been the same line. So it was infinitely many solutions. We talked about why graphing is not the best way. You need graph paper. It's hard to tell if it's a decimal. You can't see exactly where they cross. You've got to use a ruler, make it straight. So then we did a second method.
Guys, for that graphing, right? What was the form we had to use? Y was supposed to be, right? What's that called? Anybody know? Slope what? Slope-intercept form, right? And some of you guys have a hard time, and we worked on it a ton, but some of us still have a hard time getting it into that format. You gotta move stuff around. We're getting better with it, but we still have a hard time. So that's another reason why graphing is not the greatest.
Okay. What's our next method we learned? After we did graphing, we tried to get one variable by itself. What was that called? Guys, remember we take something out and plug something in for it? Substitution. Good. Okay, substitution is it's a better method because it gives you the exact answer. There's no guesswork trying to graph and see where things cross. And it's pure algebra. You don't have to be an artist to do substitution. Okay? No graph paper, no rulers. A little bit better method.
Guys, as I see some people doing it, do not worry about that sheet right now. Mr. Hager and I are going to tell you when you need it. You don't need it right now. Just listen. We're getting you guys back. You had a week of shot. Let's get you back on what we did last academic week, what we're going to do this week. So we're able to fill that in right now.
All right, so substitution is a good method. It's not a bad method, but for some types of problems, it's not the fastest. Okay, it depends on what you've got for a problem. So we're going to learn a third method. Okay, there's a couple names for it. What we're going to start to look at in a second is called elimination. I think our book calls it the addition method. Mm-hmm. Yep. So if you see either one of these names, they mean the same thing. Okay. And this is the one we're gonna look at this week.
And that's the reason why, guys, we gave you that sheet, right? Like that graphic organizer, because there's different situations for elimination. All right, there's different ways that you do it. There's like today we're going to cover the basic way, and then tomorrow a little bit more, going to do something else, and then on Wednesday I'm going to do a couple things for the equations. All right, so today, again, there's different ways to do it.
So this is section 12.4, okay, in your book. Okay, solving systems using the addition method, or it's also called elimination.
You guys remember nothing, all we're doing is listening right now. Don't worry about filling in that sheet. When I get up there on the smart board, that's when we're going to do it. Okay?
So I already mentioned to you guys this part. Okay. Previously we've used substitution. We've also used graphing. Today we're going to learn the elimination method. Okay. When you solve by elimination.
Now on your thing, on your sheet, in the little box with the dotted outline, it says when we solve by elimination, we look for have to get three things in both equations, right? You want three things happening in that equation, or it's going to be set up this way to be able to eliminate. All right. Sometimes, like today, it's just basically going to happen, but as we get going further on in the week, all right, we're going to have other things happen. So first thing we want in both equations, we want to have in one of the terms that are in the equation that I'm doing, I want to make sure it has the same number. All right? One of the terms in both of the equations has to have the same number. Right? The same number. That gets into the second thing. It's also going to have the same letter, or same coefficient, or same variable. Right? So, get same letter, same number, well, same, obviously the number will be first, same number, same letter, and then you want the sign to be different. So one of them's got to be positive, one of them's got to be negative. Right? Those are the three. Sometimes it'll just happen. All right? Other times we might have to move some stuff around and do some, do like multiply or something like that. But those are the three things from now, tomorrow, and on Wednesday. That's what we're going to have happen. Okay?
Let's see what happens if I'm going to write down an example of just two terms, same number, same letter, different signs. Okay? And I want you to tell me what would happen if you add them up. Same numbers, same letters. Now one of them has an opposite sign. What happens if you combine those two together? What do you get?
X.
So negative 3x and positive 3x. Think of like, what's negative 3 plus 3? 0, exactly. So you combine those two, you get 0. Let's try a different one. 2y, 2y, make one of them opposite. What's negative 2y and positive 2y if you combine them? What do you get then? 0. So the goal of what Mr. Roy just said, having the same number, same letter, one of them has a negative. Okay? When you combine them, you're going to get something that cancels out. You're going to get a 0. That's going to happen in every problem today. Okay? We'll show you where that happens in the problem. Okay? So I'm just trying to get you to see that idea. Same number, same letter, opposite signs. Okay? And I just showed you what I'm writing right here. Okay? So the goal of this whole method is to add two equations together and have something cancel out. We're going to cancel out one of the variables, so we don't even have to think about it right now. And we'll solve for it later. Okay, so Mr. Roy is going to show you the template that we're going to use all week.
All right, so guys, on your, whether it be test, whether it be homework, if we do a warm-up, all right, you'll have this template. Like tonight's homework, the template's already on there. It's already set up, because I know sometimes, like, you just get the problem and it's like, I don't even know where to start sometimes. And with this stuff, it helps when you're doing this elimination stuff for it to be organized. So that's the reason why we're going to give you guys the template. All right? You'll see tomorrow and on, like tomorrow, which is down here, and then Wednesday on the back, we might add a little bit, we might add another piece to it, and the directions or the steps might be a little bit different, but for the most part, it's the same template. Right? We might just be adding something here or there. So, on your thing, this is what we have. That's your first box. So up above the box on your thing, the first step is you want to add the equations to eliminate. Right? You want to add the equations that you have. All right? And that's going to eliminate. So now we're right here. Add equations to eliminate. And you already have written on your template or your graphic organizer there, it already says, is it lined up?
Mr. What do you mean by is it lined up?
Let's give 1 second and we'll get to that. All right? I just want to make sure everyone's getting this down. Justin, you with me? Or number 1, you want to write that in. Add equations to eliminate. Everybody know where we are? KJ? Huh? Yeah. I'm worried about you because you got lacrosse practice. You're not going to make the team if you're sleeping. I know you want to rest up, but. So we want to add the equations to eliminate. Notice how I have this little dotted line going vertically. All right, going up and down. Why do you think I have that there? Anybody tell me by raising their hand? Why do you think I have that arrow there going up and down like that? Okay. Anybody else want to take a shot at it? And a lot of the stuff we've done so far, stuff's kind of been like side by side. When we do these, all right, we're gonna add or eliminate going up and down. So again, I'm looking for three things, right? Eli, what's one of those things I'm looking for when I do elimination? When I'm doing elimination, I'm looking for three things, right? We just covered at the beginning of the lesson. What's one of those things I'm looking for?
These three things you said.
Yeah, it needs three things. What's one of those things?
Same number.
Same number. What else, Shelby? Same letter. Same number, same letter. What's the last thing, Dominic? Same number, same letter.
Different size.
Different signs. All right. Well, I got a Y and a Y. What's the what is there? Is the, can I eliminate the Y and the Y? Could I? Who says yes? All right. Anybody say no? So the Y I got same letter. What would the number be for those Y's?
1.
1 in both. And then look at the signs.
They're both positive.
They're both positive. Does that work?
Yeah.
Yes.
No. So I want different signs, right? So that's out of the
So
question.
your X's would work though.
My X's would work, right? Same letter, which is what, Ben? What's the letter? No, letter. X, right? Kayla just said the number's 1. I got a pause. If there's no sign, we've said since the beginning of the year, we assume that it's positive, and then we get a negative down here. So I can eliminate that. That's gone. All right? I'm going to eliminate that. It's gone. Now, I'm just going to do my math going up and down. I got 1Y plus another Y. How many? I got 2 Y's. So I'm gonna write my new problem down here. 2Y equals positive 4, negative 2, Tyler. 4 minus 2.
4 minus 2.
Yeah? 2. So, I eliminated, right? It's lined up. The X's are over the X's, the Y's are over the Y's, and the numbers, that's the regular numbers, the constants or integers are over each other too. Everything's lined up the way it needs to be.
No, you just do it like a regular.
Now, so everything's lined up, I eliminated. Sorry, Mr. Hager.
One question. Spencer, why did you cancel out those X's?
Because it's a negative and positive.
Perfect. Yeah, we get the same number, same letter. Good. Now, I go to my next box.
Wait, you don't have to do anything to it after that?
Well, I'm getting there right now. Now we're gonna, you guys may seem like, oh, Mr. Roy, like Mr. Hager, this is like, we're gonna write this stuff again. Believe me, the more organized you are with this stuff, when we go on to the newer stuff, more difficult stuff tomorrow, all right, you're gonna wanna be able to use these steps. All right, so today maybe like, I gotta write this again, but trust me, it pays off. There's a reason why we're doing this. All right, so all I'm gonna do is take what's here and bring my 2y equals 2. I'm going to bring that right over here. 2y equals 2. And write it in that box. Now it says, solve the variable that's left. That's all I'm going to do in this box. I'm just solving for the variable that's left. Chances are, more times than not, you're going to be using division. So next to the number 2 on your graphic organizer, or on your little template there, you want to write, solve the variable that's left. Use division. All right? I know, guys, that's as big as I can make them. I know some of you guys, I think we can still fit it in there. So we're going to solve the variable that's left. We're going to use division. So above that box, you want to write, solve the variable that's left, division. Now understand, tonight, or even after this, when we go to the problems or the example problems, the steps aren't going to be written on the top. Tonight, when you have homework, the steps aren't going to be written on the top. On the test on Friday, the steps aren't going to be written on the top. I have no problem, Mr. Hager has no problem. You want to use this sheet on Friday, on the test? Fine. To remind you of the steps, that's perfectly fine. Okay? But just understand, these steps aren't going to be written on the template that's on your homework or on the examples we're going to do in a little while. All right? So we want to solve the variable that's left, use division. Like Kayla was saying, what do you want to do, Kayla?
Divide by 2.
Divide by 2, right? What's the in this right here, right? This 2y equals 2. Brad, what's the variable that's left? No, the variable. What's a variable? Y, right? So again, like we've done since the beginning of the year, we want to get that by itself, divide by 2, all right? Right down here in these little circles, that's where I'm going to put my answer, all right? That's where I'm going to put my letter here, and sometimes it might be flipped around. You might write your number here and your letter here, but for the most part, like we've done all year, your number is going to be on the left, your letter is going to be on the left, your number is going to be on the right. So y equals -1. Now, even before, I'm sorry, 1, Mr. Roy. Mr. Hager saved me right there. Y equals 1. Sorry about that, guys. So, even before I pull this back and go to the next step, think about what we did last week. Exactly. Tyler, perfect. He just said it. Plug it in, right? Every problem we did last week had what at the end? How many answers? Two answers, right? How come we have 2 answers? Who can tell me? Why do we have 2 answers?
Coordinates in the alphabet.
Okay,
Now you
well,
have to plot the points.
but look it. 1 variable, 2 variables. Remember we said way back last week at the beginning, when we're solving systems of equations, we always have 2 answers. We have to solve for both variables. All right? We're still solving systems, we're just using a different method. Like Mr. Hager did at the beginning, that's why we did it. We've done graphing. We've done substitution. Now we're on elimination. It's a different way. All right? So we got y equals 1. Now, let's pull back the curtain for the last thing. Now, we're going to plug that variable we just solved for into an original equation, either equation 1 or equation 2, and we're just going to solve. Just kind of like we did, not I want to say kind of like, exactly like we did last week when we did substitution. But remember last week we had to take that big chunk of information. Like it was hard for people to understand, like this big chunk of information might have been a number and a variable, and it's taken the place of this letter. Like, I know a lot of people, it's like, well, Mr. Roy, how does that work? I don't understand. There's more than one thing, and there's only one thing here. I don't understand how that works. With this, you don't have to. You're going to get a nice letter, all right, that you can plug in for. All right? You're going to get a nice number in a letter that you can plug in for. So the choice is, when you do this, the choice is yours in terms of what you want to plug in for. Would you say that, Mr. Hager? The choice, as far as which equation you want to use to plug in, the choice is pretty much yours, right?
Yeah, I'd say pick whichever one you think looks easy.
Mm-hmm. And I know some of you guys still kind of sometimes struggle with positives and negatives. So my suggestion would be, try to pick a one that just has positives. That way you don't have to mess around with that stuff. All right? So, which one should we use? Should we use equation 1 or equation 2? Equation 1. So, based on what we just solved for in this box, the middle box, when I plug that variable into an original equation and solve, what's that going to look like? X plus 1 equals 4. Right? Now it's this basic, right? Go ahead, Marcus.
It's -1 on both sides.
-1, right? Move the stuff to get the variable by itself, and then this is gonna cancel out. X equals 3. If you wrote x equals 3 up here and then wrote it again down there, that is perfectly fine. Because again, you're used to doing that. We just want you guys to understand that, or like when we're looking at homework and stuff like that, it's easier for us and you to find that information. That's why we did it that way. All right? So, good so far. Remember, same letter, same number, different signs. That's what we're looking for. All right? So in terms of this sheet, we're not writing anything else on that sheet today. Nothing else. But don't put it away. Why would it be a bad idea to put it away?
Because you need it for reference.
Yeah, you might want to use it as the ones we're doing we're going to give you some time to practice, maybe 1 or 2. That's your reference. Tonight, on homework, that's your reference. Take it out, look at it. It's 1 sheet of paper. all right? One sheet of paper, one thing of information, then we'll add some more to it tomorrow. Okay? Perfect, so let me give you guys, now, this will do the same exact thing tomorrow. Right? We'll come in, we'll do a little, we'll do a little thing at the beginning, and then we'll fill in the next part of the graphic organizer, and then you'll get the examples for the notes that day. So what I'm giving you guys right now is the examples for the notes. All right? The examples on the notes. So you already did example 1A. That was the example that we used for that particular problem that we did on the graphic organizer. So on that sheet, guys, right, that sheet we just filled up, that top line that's filled in with gray. Take a look at that top line that's filled in with gray. What does it say? Someone raise their hand and tell me the top line that's filled in with gray. What's it say, Isaiah? The top line that's filled in with gray.
No distributed.
Yeah, just read it.
Addition, not distributed.
No distributive. So the stuff we do tomorrow and the stuff that we do on Wednesday, you're going to have to use some multiplication. You're going to have to distribute something to get same number, same sign, same number, same letter, different variable. Today we don't have to. That's one type of problem that you'll have for elimination. All right? Where it's pretty much set up. You might have to rearrange some stuff to get it in the right order. Okay? But that's one type. Right? So we're not going to have to use any as far as getting the problem set up with same number, same letter, different sign. All right? We don't have to do any multiplication. None of that today in terms of getting them set up. Like I said, we might have to rearrange some stuff to get it in the right order, right, to get everything lined up. But in terms of multiplying stuff to get them set up, don't have to do that. Okay?
All right, so looking at example 1B, anybody think they see something up there where you've got same number, okay, same letter, opposite signs? Look and see, do you have that right now?
Yeah.
Yes.
Yeah, which letters?
Negative 2y and positive 2y.
Right, negative 2y and the positive 2y. Okay, so we're going to add everything up in these equations. We're going to put the answer right here. Let's see what happens. What number is in front of x if it's not written?
1.
1. What's 1x combined with 2x? 3x. What happens when you combine negative 2y with positive 2y?
0.
This cancels out. Okay. I don't want to cross it out so I can't see it because I'm going to need it. I need one of these original equations again in the last step. So just cross it out lightly like that. Equals 2 plus 1. 3. So that's the elimination part. You just eliminated, which variable did we eliminate?
2y.
Which variable? Y. Right, we got rid of y for now. We're going to think about it later.
Guys, when Mr. Hager, when he did all the math there, right, he eliminated, he did all the math, he wrote it on the bottom of the line, all right, that addition line. Is he missing a number? He's not?
You know what?
What about negative 2y and positive 2y?
The Y's are gone.
The y's are gone, right? Just understand that you don't have, some of you guys may be like, well, you don't have to put a 0. You don't need to. We don't need to do it. It's an extra step that you don't have to do. So just understand that you don't have to write the 0 down. It's gone. Just like we doing equations from the beginning of the year. When something's eliminated, we don't put 0. All right, so just understand that.
Okay, who can tell me what's my next step? Yeah, what am I going to divide by? Go ahead, Eli. Yeah, divide by 3. Ben, what's that going to give me? What equals 1? X. X equals 1. Okay, am I done?
No.
Nope, what do I still need to find?
Your y.
Still need to find y. Dominic, now that I have x equals 1, what do I do with it to find y? Plug it into which equation?
Easiest one can be the top.
The easiest one, yeah, whichever one you want. You said the top
Yeah,
one?
why would Dominic say that the top one is the easier one?
The X is by itself.
X is by itself. If you pick the bottom one, you're not wrong. You can still, you just gotta do an extra step, right? If Dominic picked the bottom equation to plug in, what would he have to do? What math operation first? What math operation would he have to do first? Huh? No. Look at the bottom equation. It's 2x, right? What does that mean? Who said it?
Multiply.
Multiply, right? 2 with the x right next to it. Did you say it too, Eli? I'm sorry, I didn't hear you. All right? 2 with the x next to it means multiplication. You just have to multiply. All right? You're not wrong if you plug it into the bottom one. That's fine. But the top one's easier because, like Kayla said, x is already by itself.
All right, so Dominic, can you tell me, go ahead, fill in 1 for x in the top equation. What do you have?
1x equals 2.
So x is gone, right?
Or, yeah.
You're going to fill it in. So yeah, just 1.
Would you keep the y?
Yes, you keep the y.
The negative 2y
Equals 2. Okay, now we got to solve that equation. Joe, what would be my first step to solve that?
minus 1.
-1. Good. -1. So I get negative 2y. Joe, what's 2 minus 1? 1. Okay, now I got 1 step left. Savon, what's my last step?
Divide.
Yeah, by what? Perfect. Divide by negative 2. Divide by negative 2. And what does that give me, Savon, for y?
Y equals a half. Negative 1/2.
Yeah, perfect. Negative a half. That's it. That's elimination.
Wow, that's easy.
Yeah, it's pretty easy. Any question on it? So we're gonna we'll try one more of the basic ones, and then we'll look at one you gotta rearrange. Okay, so first thing you do, anytime you have an elimination problem, you gotta look at it and check. Do I have the same number? Do I have the same letter? Do I have opposite signs? If I don't, I gotta do something.
Why did you put fractions on this?
Today, because fractions are part of what we're doing.
Yes, it's nice.
Yeah, guys, the top is 1/2 r plus 2/5 s equals 15. Bottom, negative 1/2 r plus 4/5 s equals, is that 45, Mr. Hager?
Yes.
Equals 45.
Okay.
4/5 s.
Anybody see the same number,
No.
same letter?
Negative 1/2
Opposite
R,
signs.
positive 1/2
Negative.
Yep. Negative 1/2 r, positive 1/2 r. What's going to happen when we add those up? Those are going to cancel out. Okay. Now, even though we have to add these fractions, what's nice about the denominators?
This is the same.
They're already the same. So we have 2/5 plus 4/5. 6/5. What's the variable that's next to that?
S.
S. Okay, so 6/5 S.
Put that in a decimal. You really big decimal.
Equals
Okay, what's on the other side?
60.
How'd you get 60?
You add them together.
Good. Just add 15 and 45. Which letter did we just eliminate for now? R is gone. We don't need to think about it. Now we're thinking about S. What do I do with this equation?
Bring it over.
Put it in the second box. So 6/5 S. Having a 5 and an S in the same problem is not good.
Yeah, can you make it a decimal? Really easy
No, because we're going to solve it using a reciprocal, which just took my first question. All right, so now my question was going to be, how do you solve when you have a fraction in front of a variable? I just told you use the reciprocal, but what do you do with it?
What math operation?
Multiply. Okay, what is the reciprocal of 6 over 5? 5 over 6. Now this fraction is about to go away. We're going to get a nice answer. Yep. Okay, on this part, just use your calculator. Okay, or can anyone do that in their head? What's 60 times 5? Think of 6 times 5 and then
350.
think of 6 times 5 and then add a 0.
350.
6 times 5,
30.
30. 300.
Killing you into great.
And now it says to divide by what?
6.
6. Okay, so S equals 50. Okay, so put your answer down in this box.
See there, we ended up with a 50, so I was partially correct. More like off
Any
by-
any question on
I said 3.
that?
Yeah, 350 minus 50.
He's right, I said.
Okay, so now
Everybody stay with it.
what do I have to do now, Austin? Austin, go ahead. What do I do next?
Guys, come on.
You take the R.
So I got S equals 50. What do you want to do with that 50? Hold on, guys. I can't hear Austin. Go ahead, Austin. What'd you say? Think about we only have one. Yep, to solve what letter you got to get now? We got to get R. Okay. Which equation you guys think is easier, the top or the bottom?
Top.
Now the top, the fraction is a little smaller. Okay? You only have to multiply something by 2 over 5 rather than 4 over 5. So let's plug it into the top. Okay? When I do that, what happens to the 1/2 R? It stays. Nothing's going to happen to 1/2 R right now. Okay, so keep that. Plus, who can tell me what this next part's going to be?
2 over 5 times 50.
Yep, 2 over 5. And again, don't get nervous about the fraction. Just use a calculator. Okay, just use your calculator. So 2 over 5 times 50 equals 15. Okay, so in the next step, I still have 1/2 R. Now I'm going to use my calculator to do 2 over 5. I'll do that first. I just typed in 2 divided by 5. And now hit times 50. So I get 20. So now I don't have a fraction, at least for that part. Okay. What's my next step?
Subtract 20.
Good. Subtract 20. Subtract 20. You get 1/2 R equals, what's 15 take away 20?
5.
-5.
Good, -5.
Oh, it's negative.
And now we've seen this before. We've got a fraction in front of a variable. So what am I going to multiply each side by? Reciprocal, which is what?
2 over 1.
Perfect. 2 over 1 times 2 over 1. When you do that, your coefficient of R cancels out, becomes 1. What's -5 times 2?
-10.
-10. And that's it. You got both answers. So even though you might have fractions in the problem to start, the answers still might come out nice. They might not. Okay, it depends. Okay. Any question on that? All right. So far, if you look at all your problems, look at the columns. The R's were lined up. The S's were lined up. The numbers were lined up.
I just got
The last one. X's are lined up. Y's are lined up. Numbers are lined up. Well, sometimes you're going to have to line them up yourself. Like in this one. Look what happened. Are the X's lined up?
No.
No, you have an X over a Y over an X. So our suggestion is to move everything to the left. Just like this. Put all the letters on the left. leave things that aren't letters on the right. So, Mr. White, when we rewrite it, you want to put it right in the first box?
If you want to, Mr. Hager, they have rooms if they want to write it like underneath.
Underneath? Yeah.
Actually, they can rewrite it there and then solve underneath, that's fine.
Okay, let's look at this first one. Okay, so we got 2x equals 3y minus 5. Before I even start solving it, I got to rearrange it. What should I put on the other side? The 3y. Okay, the negative 5, I'm going to leave it where it is. How do you move the 3y? Subtract it. Perfect.
Guys, you know, Mr. Hager's just writing that down below, and then we'll bring it back up there afterwards.
What's 3y minus 3y?
0.
0. What's on the right side now?
Negative
minus
3y.
Bruh.
Negative 5.
Oh, good, yeah.
Now, can I combine the x and the y here? No, why not?
Those are not the same.
Different variables. Just leave it like that.
And guys, see the order Mr. Hager wrote it, right? He wrote you wrote it in like alphabetical order, right? X comes before Y, that's why you wrote it first, okay? Just like, doesn't matter whatever letters you're dealing with, all right? Put them in, I would suggest, put them in alphabetical order. This helps you to keep you more organized, okay?
Okay, so now we've done the first equation. Now we're going to look at the second one. Is that in the order we want?
Sure.
Nope, because we don't have all the x's and y's on one side. We'll do it in alphabetical, just like Mr. Roy said. So, what do I have to move in this equation?
4x.
4x, how do you move it?
Minus.
You're going to subtract and subtract. 4x minus 4x, what happens there? Cancels out. Now, who can tell me what's going to be on the left-hand side, writing it in alphabetical order?
3y minus 4x.
Okay, but we want it in alphabetical order. That is good.
4x plus 3y.
What kind of number is in front of x?
Oh, negative 4x.
It's a negative 4x. What kind of number is in front of y?
Positive.
Positive. Negative 4x, positive 3y. How do you know that's positive? There's no sign in front of it.
There's no negative.
Right, if there's no negative, it's automatically positive. And what do you still have on the right-hand side?
1.
1. Okay. Here's our new second equation. Let's write that one below the other one. Let's see what happens. Negative 4x plus 3y equals 1. If you look at that and make it a little bigger. Do you have same number, same variable, opposite signs there? Just exactly. Which variable are we looking at that's going to disappear? Y. So just by rearranging it, something's automatically going to eliminate itself. And you guys just said it. It's the y. Again, don't erase it because you're going to need one of these equations to come back to. Okay. Now let's add these up. Ben, what's 2x minus 4x? Negative 2 what? X. And negative 5 plus 1. Good, negative 4. Now from here out, it's just like the ones we started with. Once you rearrange it,
Does that say negative 3x?
negative 2x. Okay, what do I do with negative 2x minus equals negative 4?
Fill out.
Well, before I'm kind of out of space here, so where am I going to go put it now?
Next box.
Let's put it in the next box. Okay, so in this first box, you've got both x's and y's. Once you do the second box and the third box, you should never have two letters in either of these boxes. Okay, that's a good way to remember. In the second box and third box, you should never have multiple letters. Just one letter now. Who can tell me what I do from here? How about Brian? How do you get x by itself? Well, what operation is this? Negative 2 and x, they're being what? Multiplication. What's the opposite of multiplication? Divide. And what's the number we're trying to get rid of near x? -2. So that's gone.
X equals 2.
X equals 2. Good. Now we done?
Nope.
Of course not. We got one more empty box. We're going to fill that in. Mr. Wright doesn't put these boxes here because he likes it. All right. So I got to take that 2 and plug it in for x. And now you have a choice here. Okay, what I would do is I would go back to one of the very original equations. Why? Because I know they're right. They were given to me. Okay? If I use one of these equations, chances are I would have already gotten x wrong anyway. But I like to go back to information that was given. Okay? So let's pick equation 1 or equation 2. Which equation do you think looks easier to plug into? First one? Okay. Let's do the first one. Okay, if we're going to use the first one, who can tell me what I get when I plug in to the first one? Yep. Savon, I'm just going to write it in 2 steps, just so everybody sees how he did it. He took 2, and he filled it in for x. Okay? So he said 4, which is correct. I'm just going to do that as a second step. Savon, can you keep going? 2 times 2 equals, what's on the other side?
Y minus 5.
Good. What'd you say you got for that again?
4.
4. All right, I got 2 steps left. Plus 5, good. Plus 5. Chelsea, what's 4 plus 5 going to give me?
It's 4 plus 5. Thank you.
And my last step. Tyler, what's my last step?
Me?
Yeah.
He meant that.
I got you.
Divide.
Good. Divide by what?
3.
3? What's 9 divided by 3?
3.
Good.
Yeah,
So-
that's just one of those situations I was talking about earlier, where you might have the y on the right-hand side. That's fine. If you write it on the left, it doesn't matter. If you have the other way around, y equals 3, that's fine too. 3 equals y, means the same exact thing.
Is it okay if you take the problem that we switched it up with?
Yeah, you could
Oh,
take...
yeah.
That's what I did. I took
That's
the
fine.
problem that we like mixed it up.
We rearranged like we did
Yeah.
last week.
Yeah.
You could take this x equals 2, and you got 4 choices where you want to put it. You could put it in equation 1, equation 2, the new version of equation 1, or the new version of equation 2. It doesn't matter.
Wait, did that say 3y? I'm so copied that.
So y equals 3.
No,
Yep, 9 equals 3y. Okay, next example we're going to give you, we want you to try to just line up the like terms first.
We're gonna go step by step. All right. So the next equation that we do, all right, write it in right now. More time for the next one. All right. So, Justin, tell me, everyone, look at me. Look at me. Look at me. This top equation. Yes? No? Tell me. Yes or no? Tell me.
I do not want to. Yes means no doing.
Yes or no?
No.
Yes or no? Yeah?
Yes or no?
Yeah?
Why?
What do you say, Dan? Yes or no? I guess you say no. Dan said no. Emma, what do you say?
So confused.
Emma, yes or no for the top? Set up, yes or no? Is this good? Is that set up correctly? Is it lined up?
Oh, that's what you're saying, yes or no?
Is this lined up, yes or no?
No. Yes.
X, Y, number. Yes.
Yes.
Okay, now. Yes, sir. Bottom one.
No.
Now.
Lot of no's. Lot of no's, lot of no's. Okay, all right. If you say no, you say this isn't set up right, prove it. What's wrong with Laura?
You're supposed to have
Yeah, Laura.
the x and then the y that number.
All right, so what you do?
7x plus 3y equals 9.
You're wrong.
So you added 3y, and then over here too, right? Added 3y here. Good. All I'm gonna do is, I'm gonna bring down equation 1 and just rewrite it. 4x minus 3y equals 3. And then I'm gonna do what Laura just said to do. 7x plus 3y equals 19.
I'm so confused. Wait, what does that do?
I brought this equation.
I know I am.
If I'm going to review it, listen. Okay, just listen. I took the top equation and just wrote it because the top one was fine. I had alphabetical. I had on the left hand side. I had alphabetical order. All right, and then I had a number after the equal sign. Perfect. Bottom one, I had a letter, number, another letter. Like Laura said, that's a problem. I need my letters on the left side. Right? Letters on the left. Letters need to be on the left in order to get this here, like my friend Mr. Gushlaw says, give it a ticket, move it over here. Right? Give it a ticket, right? Bring it over here. Right? I also say that because his dad's a cop. He knows how to give tickets. So, now, done for now. Everything's in the right order. Now, take 5 seconds. Take 5 seconds in your brain. Look at this problem. I don't care if it's on your paper or... All right, 5 seconds in your brain, on the board or on your paper. I want you to decide. Don't yell it out loud. You hear me, Isaiah? Don't yell it out loud. I want you to take 5 seconds in your brain and decide which equation, Benjamin, take 5 seconds in your brain and determine which equation you're going to eliminate. 5. And when I get to 1, everybody say what letter. Ready? 5, 4, 3, 2, 1, go. Huh?
X.
Y, right? Same number. Listen, same number, same letter, different signs, right? 3, Y, positive, negative.
You did that backwards. It was negative, positive.
Oh, negative, positive. You paying attention? Eliminate, bye-bye. What do I write here? Do the math, right? 7 and 4x, 7x, 11x
Equals 22.
equals 3 plus 19, 22. Where's this go?
On that side.
Where's it go?
Other bar.
Right here.
On that side.
11x equals 22.
Divide
Divide by 11, like KJ said.
by 11.
X equals 2. Now, Mr. Nermi, what do you want to do now? Huh? What you just solve for? Okay.
That's up for Y.
All right, how do I do that?
X is 2.
Your buddy, Mr. Gushlaw, is down here saying, plug it in, plug it in. Okay, where?
That's right.
I don't know. Spencer, where can I plug this in? Which one? Where? This one? Okay, so what am I going to write? Tell me, Spencer.
4.
Yeah.
You're wrong. Parentheses.
Good, nice job, guys. Keep going.
Minus 3y.
Yeah. Equals 3, right? 4 times 2?
8.
Now what?
Subtract.
Divide. Subtract, I meant.
8.
Can't see.
Negative 3y equals
Negative 5.
negative 5.
Divide by negative.
Divide by negative 3, right? Now, y equals, stop. Sam S. Yeah, Sam S isn't here today. Sam S. What am I going to get? So I got negative 3y equals negative 5 over negative 3. So y is going to equal what? Haven't got to that part? I heard, go ahead. Victoria, go ahead. What you say?
Got this.
Okay, what's it gonna be? 5/3, 5/3? I 100% agree with you. Y equals 5/3. It's okay, we're not requiring you guys to check them.
That's 1, 2, 3.
You do not, yeah, it'd be like 1 and 2/3. You wanna make it a mixed number, you don't have to though. All right, this is good, leave it like this. Listen to me, tonight on your homework, I think there's 2 that you have to rearrange. I'll remind you before you leave. The 2 on the back side, you have to rearrange, all right, on your homework. Just like we did. If you're not sure, look back to the examples from the notes. Alphabetical order, okay? Next, we'll go next. Now, I'm gonna get ready for the size. I'm gonna get ready for the, Mr. Roy, Mr. Hager, come on. So, 2, I promise you, we're gonna do better. We're gonna do better with these on Friday. I promise you.
Yeah,
All right.
you wanna start us off on Monday?
So, two packages have a total weight of 39 pounds.
Yeah, the package is bad.
What's 2 of them actually? One package weighs 7 pounds more than the other. Find the weight of each package. Doing 2 equations, right? What 2 things?
X, Y.
We can do X and Y. What are we trying to find? The weight of one package 1 and
2.
package 2. So two packages. Like what I do, guys, is let's use red. 2 packages, like Kayla just said, X and Y, have a total weight of 39 pounds. So this total weight of,
X plus Y equals 39.
right, that total weight of means equals. All right, that total weight of means equals, and then we just have the number 39. Kayla just said it, our first equation, X plus Y equals 39. That's for that. So that was the basic one, right? Nothing really had to do any minus or plug in any numbers, all right, with the variables. That was the basic one. Now, one package. How do you want to represent that one package? That's X, right? Cross that out. Make it X.
X times.
Weighs, hold on, Kayla. Thank you, though. Weighs 7 pounds more than. Mr. Fayford, what's more than mean? You know.
It means more.
Yeah, what math? Plus, good. See, I told you knew it. More than the other. What's the other?
Y.
Y. So the other becomes Y. Find the weight of each package. So we already used the first set of information. We went through, we broke it all down. Now, we got this. This bottom equation. All right, I'm going to look a little bit more.
X times.
All right, so one package, this bottom equation, I don't care about X plus 1,000, I don't care about that. All I want to know is this. What variable is that bottom equation going to start with?
X.
X. 1x, X, same thing. X. 7 more than.
Times 7.
No, however, Justin just said. What's more than mean, Justin?
Oh,
Plus
7 more.
7 more than the other. What's going to separate the two? Equals. All right? So that's that. One package, X, weighs 7 more than, I just broke it down, 7 more than means plus 7, equals the other, which right now is Y. So all I did was went through, crossed out information, all right, plugged in letters, all right, knew what certain phrases meant in math, changed it to what operation they represented. That's all I did. I wrote them out. Now, top equation, good or bad?
Oh, good.
Let me put it, I'm sorry. Lined up? Yes or no?
Yes.
Sure, right? Perfect. Now,
So it was good.
bottom,
No.
bottom.
No.
No bueno.
No bueno. What's in the wrong spot? Actually, what two things are in the wrong spot?
Y and 7.
The y and the 7, right? So, what do I need to do?
Subtract.
Subtract what?
7.
Subtract the 7, and also what? It's gonna be like a double switch.
Subtract 7 and y.
Subtract 7, right? Move it over here. Subtract y, move it over there. All right? So I'm gonna minus 7. All right? Move that over here, and I'm gonna subtract y and move it over there. All right? So it's x
Wait.
plus y equals 39. All right? Then what I rearranged is x, what am I bringing over? Minus y. And on the other side of the equal sign is what? Minus 7. Again, last week we solved these using substitution.
Does that say 39?
Yeah, 39.
Why did you do it that way?
Huh?
It seems
What's up?
Why wouldn't you just subtract the x and then flip it?
Kayla, you're confusing me.
We could have done the one Kayla's saying, guys, we could have minus x, brought it over here, then it would have been minus x.
And then just flip it.
It would have been 7 equals negative x minus y. And we could have just flipped it around. If you did it that way, that's fine. Okay? We did it this way, that's fine. Now, Ryan Martin, here, we rearranged everything, right? Which variable is going to be eliminated?
The x or the y?
Don't listen to Kayla, you be your own person, you figure it out.
Rufus, why?
No, he's not.
Y. Right? The y, right? Look at, again, hey, do you want to,
You think I'm going up there?
the floor's yours.
Yeah.
I'm just making sure.
You think I'm going up there?
Just making sure. So, listen, yeah, Rufus, whatever you call him. Again, what are the three things I'm looking for?
Same number, different sign, same letter.
Good job, Isaiah. Right, I got it here, right? My letter's y, my number's 1, plus, minus. I did it right that time.
Hey.
So I'm going to get x equals 39 minus 7. Anybody know?
A number.
Huh?
32.
32. Well, x equals 32. Look it. I didn't have to do, I'm sorry, 2x. My bad. I didn't add the x and the x. Thanks, Mr. Hager. Sorry you're looking at me. So rewrite here. 2x equals 32.
Yeah.
What do I got to do?
Why?
Sorry, I made that rhyme. X equals 32 divided by 2.
16.
Is it 16?
No. No. 15 and a half. I'll call it 15 and a half.
16.
Be 16, right?
No.
Yeah, because, yeah.
Have it.
16, because 15 times 2 is 30. All right? So we get x equals 16. Sweet. Austin, now what? You know this. Which one do you want to use, top or bottom? Yeah, we move this around down here. Let's just use the top one. All right? You can use, like Kayla said earlier, you can use the original. You can use what you rearrange. There's no wrong way to do it. All right? So what am I going to write? What am I going to write, Austin?
16
Yeah?
plus 1 39.
Now what?
Minus 16.
Minus 16. Minus 16. Y equals 3 minus 1.
2.
Guys, 9 minus 6. Y equals 23. And there we go.
What is that? Is your Y?
That's a Y. It's a really bad Y.
Hey, leave him be. He likes to write fast.
Y equals 23.
Man.
All right, so.
Wait, let me just copy.
Oh, yeah, finish copying down.
I
Sorry.
decided to die.
What?
It decided to die.
What does it do?
Okay, so let's look at this last example.
Don't get.
Okay, Mr. Wright highlighted the 2 pieces of information. Okay. Let's start with the first one. That one's tougher. Okay. What letters might make sense to use here? Sure. L and what? J?
Hey guys, I'm just saying, last example of the day, be a great example to put on the test on Friday.
Yeah.
Because I know a lot of people that might not write it down. So I'm gonna definitely keep this in the back of my mind for Friday, just so you know.
Usually when teachers say
All right.
that, it's always on the test.
So your first problem, it says Lupe has a certain amount of money. Okay, so it's giving you a formula for how much money Lupe has. Okay, now we got to read how much Lupe has. 9 less than Juanita. Now be careful when you write the subtraction here. When you see 9 less than something, you got to remember to do something. So how would you write 9 less than Juanita?
9 minus
Think of it as Juanita's amount
Oh, J
decreased by 9. J minus 9.
That means you got negative 9J.
Listen to what I said this
Okay.
grade too, when I had L minus 9 equals J.
So we could rewrite it as L plus 9 equals J, but it's got to be L equals J minus 9.
Oh, sorry guys, I just screwed that up.
Right? Now the next part, okay, this is the easy equation. Together they have a total of $53.
I did that one first.
Yep, what'd you get for that one?
I did L plus J equals 53.
Good. Now if you look at that second equation, are the L and the J in the right spot?
Sure.
Yeah. L and J are already on the left-hand side. How about the top equation?
No.
Nope. So we're going to fix it. How do I fix it so that L and J are on the same side? Subtract J. Subtract J. What's on the left-hand side?
L
L what?
minus J.
Equals what?
Negative.
Okay.
And then flip it.
So then write these two equations.
Oh, no.
This is our first equation. We just fixed it. L minus J equals negative 9. We just put the J on the other side. Was the bottom equation okay?
Yes.
Yeah.
And your J's cancel.
And the J's cancel. How many L's do we have?
2.
What's 53 take away 9? 44. Right? So negative 9 plus 53 gives you 44. What's L? Yeah, divide, and what do you get?
22.
So L is 22. So now we can use our second equation. L plus J equals 53. So 22 plus Juanita equals 53. What's my last step? Subtract 22. 3 minus 2 gives me 1.
31.
So Juanita is 31. Okay? All right, so for homework tonight, Kate, Mr. Roy, and I are going to pass out a worksheet.